October 20th, 2025 is supposed to be an ordinary date in the slow, methodical calendar of amateur astronomy. The sun is calm. The solar maximum warnings are weeks away, and most backyard observers are waiting for cooler weather to resume nighttime imaging. Then an unremarkable username, Dobsonian Power, posts a single frame to X, Reddit, and an astronomy Discord server. The file is raw fits, stripped of curves, flats, bias, and every cosmetic filter. All it shows is the bright disk of our star, an inverted color palette, a smattering of hot pixel noise, and at upper left a pencil-thin spear of light stabbing directly at the solar limb. The frames fits header lists precise coordinates: 13 hours, 48 minutes, and 57.33 seconds right ascension, 08 degree 25, 54.3 declination. Those figures exactly match NASA's public ephemeris for an interstellar visitor labeled 3IATLAS. A collective shiver runs through every hobbyist who downloads the file, because one detail instantly violates the most basic rule in cometary physics. There is no tail trailing away from the sun. Every student of astronomy, every child who has ever seen a media photograph of a comet, knows the textbook geometry. Solar radiation warms frozen volatiles. Sublimated gases push dust outward. The solar wind then blows that mixture straight away from the heat source. Wherever a comet goes, a streamer of vapor and dust points in the anti-solar direction. That geometry never changes because the vector of photon pressure never changes. But in the Dobsonian Power frame, the streamer points toward the sun worse. It looks nothing like a chaotic plume. The feature is uniform, narrow, collimated, almost technological. With the original file, now public, image debunkers attack immediately. Probably a D-Bayer issue, suggests one. Might be overcorrected flats, says another. A professional solar imager named Elara drags the fits through PixInsight and extracts the hot pixel map. She overlays that mask on another amateur's image captured 5 minutes later, hundreds of kilometers away. The pixel defects do not line up, but the polar bright spear does. Same orientation, same length, same luminance profile. That rules out camera noise or bad calibration. The jet is, at minimum, a real photon source. Next come the orbital dynamics people. They calculate that 3I/Atlas, discovered only 8 months earlier, is inbound on a retrograde path, yet its inclination relative to the ecliptic is barely 5 degrees. Statistically, a random interstellar rock should arrive from any direction. The chance it threads the thin plane where Earth, Mars, Venus, and Mercury all orbit is about 2%. That improbable alignment would be trivial if everything else looked normal, but the alignment appears beside a forbidden jet and an invisible tail. The improbable is now suspicious. More red flags emerge overnight. Crowdsourced photometry puts the object's absolute magnitude several orders brighter than the Oumuamua visitor of 2017, implying a solid body at least 5 kilometers wide. If the same power law size distribution that governs our own Oort cloud comets applies to galactic debris, astronomers should have cataloged thousands of little Oumuamuas before finding a Leviathan this big. Yet the catalog shows the opposite sequence. One tiny shard first, then one giant. Either the statistics failed, or this newcomer is not a product of random shrapnel, but a deliberate, engineered mass. Meanwhile, mainstream observatories go eerily dark. NASA's Solar Dynamics Observatory, a spacecraft guaranteed to stream ultra-high-resolution solar movies every minute of every day, shows blank frames labeled Note Data. A terse engineering notes cites instrument reset, restart in progress. At almost the same moment, HiRISE aboard the Mars Reconnaissance Orbiter enters safe mode after an unexplained gyroscope spike. The very camera that would have snapped mural-sized close-ups when Atlas passed by Mars 2 weeks earlier. Agency status pages list rational reasons. Electronics age, radiation hits, spacecraft need downtime. But to a growing online audience, the gaps look coordinated. If someone wanted to limit what the public could see, Temporary safe modes at the exact moment of maximum curiosity would be a perfect tactic. Content creators race to package the story. TikTok conspiracists splice the raw frame into oversaturated horror teasers. Reddit's r/spacebegs moderators to create a megathread. Podcast hosts ring up every astronomer who ever published on non-gravitational accelerations. National outlets hesitate. Few editors are willing to label a potential NASA embarrassment as real until a credentialed name utters the words out loud. That name arrives within 48 hours. Avi Loeb, former chair of Harvard's astronomy department and the man who dared to call Oumuamua possibly artificial, publishes a short article. He doesn't tweet an emoji or record a casual podcast. He posts a mathematically dense preprint summarizing 7 anomalies: trajectory, size, jet orientation, tail absence, premature outgassing, exotic chemistry, and conjunction timing, and attaches a probability estimate. In his Bayesian analysis, there's a 30 to 40% chance that 3IATLAS is technological. Within an hour, the servers hosting the preprint slow to a crawl. The internet loses its collective mind, but silence from official astronomy persists. The gap between public speculation and institutional caution becomes a canyon. In that canyon, homemade science flourishes. GitHub repositories appear with Python notebooks for automated light curve analysis. Volunteer coders write machine learning tools that hunt for suspicious straight-line edges in stacked H-alpha frames. Hundreds of gigabytes of calibrated data pour in from backyards across 5 continents. Never before has an interstellar object been placed under such a crowdsourced microscope. The frame that should not exist has forced open a question older than written history. Are we witnessing a cosmic ice ball or the deliberate arrival of alien hardware? Any honest attempt to judge 3I/Atlas begins with the raw mechanics of interstellar orbits. Comets born in distant star systems are flung outward by complicated gravitational three-body dances. They travel for millions of years, sampling every random inclination. Only a tiny subset will ever slip through the ecliptic plane that the major planets occupy. Earth's orbit occupies a wafer so thin that hitting it by accident resembles landing a dart on the narrow edge of a spinning coin. Yet Atlas does exactly that. If natural, it is freakishly lucky. If guided, it is simply well navigated. Next, evaluate size. Telescope surveys of star-lighting occultations place an upper limit on Atlas's diameter, at least 5 kilometers. Combine that with the object's brightness and assumed reflectivity, and mass estimates explode past every interstellar object recorded till now. Within comet science, size distributions follow steep power laws. Big ones are exponentially rarer than small ones, meaning a civilization that looks up should see thousands of harmless pebbles before meeting one skyscraper-wide behemoth. The catalog says otherwise, suggesting an external hand picked the order of arrivals. Third comes the discovery that Atlas began outgassing at 4.4 astronomical units, farther than Jupiter, where midday sunlight equals little more than a tropical nightlight. Typical comets wake only when water ice can sublimate, usually within $3 Australian. Atlas lights up early and not with water. Its carbon dioxide to water vapor ratio hovers near 8:1, the highest ever logged. That implies either an interior of exotic CO2 ices or a reservoir of something we store inside rocket stage propellant tanks. Anomaly 4 is the composition's metallic fingerprint. Keck 2 absorbs the object's light and returns an emission pattern, screaming nickel. The associated iron lines are mysteriously absent, yet chromium appears shoulder to shoulder with nickel in the identical ratios used on Earth to forge Inconel, an alloy born in 1932 for heat shields, turbine discs, and reentry skins. In nature, iron and nickel congeal together in planet cores, asteroid melt droplets, and ancient meteorites. Only industry bothers to separate them. To find that ratio adrift in space is like walking into a forest and tripping over a stainless steel coffee mug. Either nature learned metalwork, or someone dropped it, Anomaly 5 is the shape of the dust. Hubble photographs confirm an anti-tail, a dust ribbon directed sunward. Geometry can indeed trick viewers. When Earth slides through the orbital plane of a comet, the tail's curve can project forward. But every anti-tail sits inside a halo of debris personal to its comet. Atlas's halo is anemic. The dust lane is too crisp. It acts less like a streamer of debris and more like an exhaust plume. Anomaly 6. Nickel and cyanide loss rates. Keck quantifies nickel vapor escaping at roughly 0.9 gs superscript 1, while CN radicals escape at 3.9 gs superscript 1. Compare those values against the comet median, and Atlas is thousands of standard deviations above normal. If chemistry alone produced the metal vapor, it required a planetary oven or some exotic particulate sieve unknown to solar science. If not chemistry, then perhaps factory-grade smelting and venting. Finally, Anomaly 7. Timing. Atlas reaches solar conjunction on October 21st, hides behind our star for 8 days, and then executes perihelion on October 29th. In rocketry, the Oberth effect dictates that a thrust performed at maximum orbital velocity multiplies the energy gained. The sweet spot is the instant of closest approach to your gravity well. Converting fuel mass into delta V at any other place in the orbit is mathematically wasteful. Thus, if you were an automated probe planning a major maneuver while avoiding detection, you would schedule that burn where Atlas schedules it, during conjunction, invisible 1 solar diameter away from every Earth telescope. Enter Avi Loeb and his informal Loeb scale. 0 represents an ice rock you'd use for high school lab demos. 10 means a spacecraft with flashing lights spelling WECOME. Atlas ranks 6. That number terrifies classical comet researchers, delights astrobiology dreamers, and fascinates data scientists who have never cared about space until today. Still, the skeptical mantra remains. Extraordinary claims require extraordinary evidence. For every anomaly, a natural patch exists. Trajectory luck can happen. Size distributions depend on detection biases. Early activity can be chemical quirks. Nickel without iron could, in theory, result from weird metal organic compounds. Anti-tails can be illusions. Conjunction timing can be coincidence. 7 coincidences pile awkwardly high, yet none singly screams alien. The debate pivots on collective probability. Does one accept 7 improbable explanations or a single exotic explanation? That philosophical standoff fuels an internet war. On October 29th, the solar glare eases. The first amateurs in South Africa get a wafer-thin slice of pre-dawn sky and immediately call out coordinates. Atlas is there. No obvious fragmentation cloud surrounds it. Its magnitude is only marginally brighter than pre-conjunction predictions, not the exploding flare a dying comet might present, nor the sharply diminished spark that total breakup would leave. The jet angle appears to have pivoted a few degrees, but early frames are low resolution, and the internet demands confirmation. As daylight creeps across time zones, the hobbyist grid hands off the target from Africa to Europe to Eastern North America to the American West. Each batch of exposures is dumped into the public repository and digested by the swarm of homebrew algorithms. Within a single rotation of Earth, the code flags 3 tiny, consistent dim points trailing several thousand kilometers behind Atlas. They drift outward on individual vectors. They twinkle with irregular cadence, unlike simple dust motes. They look, in short, like children of a mothership. Professional observatories swoop in. Lowell obtains an hour of dark time between Venus glare and twilight. The large monolithic imager resolves one companion at roughly 50 meters across, reflecting too much light for a loose pile of rubble that size. The reflectivity again suggests polished metal or high albedo composite, not carbon-rich dust. A week later, with more drift, 2 of the blips streak across a star field, revealing an elongation ratio near 7:1, reminiscent of Oumuamua's signature cigar silhouette. The iron lines remain missing. Nickel lines, however, spiked by an order of magnitude. Whatever happened behind the sun vented or exposed fresh industrial alloy. If one accepts that premise, only two big pictures remain. Benefactor probe. The mini-craft settle into quasi-stable heliocentric orbits, none Earth-crossing. One begins broadcasting at X-band frequencies in precisely timed bursts. Prime numbers, Fibonacci, hydrogen spin-flip signature, simple pictograms. SETI arrays isolate the signal. It is real. Humanity receives its first undeniable hello. Panels of linguists, cryptographers, and astrophysicists assemble. But the first requirement is humility. We are a junior species confronted by an older sibling. The knowledge could be a blessing. Power sources that render fossil fuels obsolete, vaccines that erase cancer, gravity mathematics that extend life to the outer planets. Or it might be inert, an encyclopedic time capsule whose greatest gift is cosmic perspective. Either way, the core emotion across Earth is awe. Neutral depot. The companions change nothing. They do not signal. They do not adjust course toward Earth or any other planet. They assume resonant solar orbits, perhaps Trojan points, perhaps heliocentric halos. Years pass. Engineers eventually dispatch a slow, robotic mission to intercept one. Up-close imagery shows where marks, docking collars, and QR code-like glyphs etched in alloy the strength of sapphire. Inside are empty cells, perhaps once filled with resources or data modules. These are refueling cans for a larger logistics chain, and their creators may have vanished a billion years earlier. The existential impact on humanity is still seismic. We confirm we are not the first to cross near our sun. The universe is not sterile, but littered with remains, and we, latecomers, have stumbled across one service station in a network that spans light years. Berserker Scout. The mini-craft do not spiral harmlessly. Instead, their ground tracks intersect Earth's orbital path within 6 weeks. Radar snapshots from Goldstone reveal dense, nickel-shining darts. Delta V analysis implies they will intercept Earth at 30 kilometers per second. Planetary defense sound the alarm, but no nation holds a kinetic interceptor ready at that closing speed. Emergency launch windows would require monumental international cooperation, and even then success is mathematically doubtful. Cameras on the dart switch on just once, beaming imagery back toward Atlas or beyond. Are they weapons, kinetic slugs, biological payloads, or instrumented scouts? Nobody knows. Debate collapses under the reality that time is short. Which timeline becomes history depends on observations unfolding in real time, right now. The object's future behavior will either soften the 7 anomaly stack, leaving them as eccentric corners of natural science, or harden them into courtroom evidence that someone engineered Atlas. The only scenario the universe does not tolerate is the desire for certainty without data. Human curiosity is being graded. We will pass by chasing the evidence wherever it leads, or we will fail by burying anomalies under convenient denial. A third outcome, forever uncertain, lurks if the signals never cross our detection threshold, if the probes subtly evade, if the physics plays an immaculate trick. Uncertainty might be the hardest of all, because then every schoolchild for generations will ask, did our ancestors meet the neighbors and just not realize it? One thing is already undeniable. For the first time since the species emerged, an interstellar object has attracted more open-source collaboration, more mixed emotions, and more primetime minutes than any deep space probe ever launched by governments. Whether Atlas is ice or alloy, comet or craft, dead relic or watching eye, it has made the entire planet look up together. That alone may be worth the drama. So keep the backyard rigs humming, keep the code compiling, keep the debates polite but fierce. The photograph that should not exist tore a hole in complacency. The 7-layer anomaly cake refuses easy baking instructions. The 8 blind days condensed more anxiety and hope than a decade of routine Mars launches. And the next pages are ours to write, either with the ink of discovery, the ink of warning, or the ellipsis of eternal mystery. Because when the sky itself offers a final exam question. Are you alone? The only unforgivable answer is to avert your telescope and pretend the test never happened.